Welcome students. Now in this video we are going to see computer aided designing, computer aided manufacturing and computer integrated manufacturing system. So let us start with computer aided designing. This is also called as, in short, CAD system. CAD, C-A-D, computer aided designing system. So in this CAD system, this involves the use of the computer to create the drawing, designing and the geometric models of the component or the parts. So what is CAD actually? So CAD is nothing but it involves the use of computer to create the design, drawing and geometric models of the component and geometric model of the parts or the component. Now see, in this computer aided designing, there is completely elimination of traditional drawing board, isn't it? So here the elimination or replacement, rather we can say, of traditional drawing board, and now the users can make the drawings or the section of drawings on the computer monitor. So this is basics of the CAD system. So there is involvement of the computer for designing, drawing and making the geometric models of the parts of the components. So if you really want to compare between the traditional designing and the computer aided designing, so let us discuss one example. Now say suppose I am going to design a shaft, okay, and the power is transmitted by the shaft, say around 10 kilowatt, and it is rotating with the RPM, say 500 revolution per minute, and the shaft is having the cross hole of say phi of 10 mm, isn't it? So this is a shaft, say, and it is having this concentric or cross hole of say phi 10 mm. Okay, now see, in conventional designing, what we are going to do to find out the dimension is nothing but the diameter of the shaft. So we are using the two criteria that we are having, that is the rigidity criteria and strength criteria. By the strength of material, you know very well what is the rigidity criteria. The rigidity criteria says that is torque divided by polar moment of inertia is equal to g theta divided by L, modulus of rigidity into angle of twist divided by length, isn't it? Or by the strength criteria, what we can write? We can write torque divided by IP is equal to tau divided by this R, shear stress divided by R, that is distance from the center, okay, centroidal distance. Now see, from this, whatever the diameter we are getting here, the D max, that is the maximum of these two is our diameter that we are considering in the design. And at the same time, what things are to be calculated. So we have to design the value of factor or stress concentration factor, stress concentration factor we have to design it. Okay, and generally in conventional designing we are taking as the factor of safety as a 2. The factor of safety कितना लेते हैं हम जनरली इसमें 2 लेते हैं. But see, now the same thing we are going to compare with the computer aided designing. So here basically if you compare this conventional and this computer aided designing, so in the conventional designing system, the entire body is taken as a single element. The entire body is taken as the single element and the analysis is done, isn't it? So that is a basic thing. And whereas in case of the computer aided designing, this body is getting divided into finite number of elements. So this body, suppose, get divided into finite number of elements. So because of that, what is going to happen? So as the analysis is done as the elemental analysis. Please remember, conventional designing में क्या था? The entire body was taken as a single element and the analysis is done. Therefore, see, the factor of safety was high and we need to find out the stress concentration factor. But when I am dividing this body into number of finite elements and I am doing the analysis of a single element, isn't it? So definitely the results are going to be more accurate, and because of the small cross section, the stress concentration factor is going to reduce. How much? Generally in designing with the CAD, the stress concentration factor now is equal to 1. We need not to consider that because of the smaller cross sections that we have considered for the analysis. And because of this computer aided designing, now we are dividing this body into finite number of elements and doing the analysis, that is with the finite element methods. We know this, so that the factor of safety is also now is come down to 1.25. So see what a huge difference between the factor of safety with the conventional designing and with the CAD designing. Say for example, I have designed the crane hook for the 8 tons, but keeping a factor of safety 2, I will confirm that the customer should use it up to the 4 tons, because factor of safety 2. So whatever the amount of material, the designing cost, manufacturing cost, all these are wasted for the next 4 tons. Yes, no doubt factor of safety we have to consider, but see here, when the factor of safety come down to the 1.25, so I can guarantee that the customer can be used that same crane hook up to say 8 divided by 1.25 up to 6.4 tons, or around 6.5 tons, that I can give him the conditions for the use, isn't it? So like that, definitely factor of safety is going to decrease. We need not to have the stress concentration factor. Generally it is 1 in case of the CAD design, computer aided designing. So very much important thing is here that conventional designing में single body है, computer aided design में क्या है, body get divided into number of elements, finite elements, and analysis is done. So more accurate results that we are going to get by using this CAD system. Okay, so that is the thing. Now if you look at this CAD, what are the inputs to the CAD? So what inputs that we have to give to the CAD? So number 1, Second is the approximate shape. Third, we have to give the material properties. And fourth, the allowable strains. So this is the input, or the first stage, the input we have to give to the CAD. So the loading conditions, how is your loading, what is approximate shape, the material properties that you are going to use there, and the allowable strains. So once you have this input, the input required, then there is, what are the process steps? The process steps. So in process step, first of all, we have to generate the 2D drawing. Okay, we have to generate the 2D drawing, then export this drawing to the analysis package. Okay, for the analysis, whatever you are requiring here, that software. Then go for the geometric modeling or geometric model. Once you get this geometric model, solid geometric model, isn't it? Solid geometric model. Then what we are going to do? Then you are going to divide it into finite numbers, finite elements, say, isn't it? After that, go for applying the loading conditions. And after applying loading conditions, you are going to get the stresses and strains, isn't it? Now once you get the stresses and strains, we have input as a allowable stresses and strain. So compare this stress and strains with allowable stress strain and do the changes if required, actually, unless and until the stresses and strains are less than or equal to the allowable stress and strains. Okay, so these are actually the process steps we are using in the this computer aided designing. And once you have this process inputs, then definitely we are going to look for the output, what output that we are going to get. So सबसे पहले क्या मिलेगा? So two-dimensional production, two-dimensional drawing available for the production, we can have the bill of material, that is BOM, and now we have got the values of the stress and strains. So this output, see, these are the outputs that we are going to get from this CAD, and now this output we are using into the, so these outputs we are using in the computer aided manufacturing. So this is about the computer aided designing. So here the use of computer for drawing, designing, making geometric modeling. We have seen the various steps, we have seen the inputs, process steps and the output. Now this output we are going to use in the computer aided manufacturing. Now see, what is computer aided manufacturing? CAM. Computer aided manufacturing, nothing but what? CAM. So here in computer aided manufacturing, the many steps in the manufacturing are going to assist by the use of computer, starting from the ordering stage. Okay, so whatever the activities, say for example the scheduling is there, process planning is there, manufacturing is there, inspection, total quality control and management. So all these activities, so whatever the activities generally we are required in the case of manufacturing, these all activities are assisted by the use of the computer in it. It is known as computer aided manufacturing. So after seeing the computer aided design, let us talk about computer aided manufacturing, which is nothing but CAM. So here CAM actually involves the use of computer and computer technology in all the phases of manufacturing, say from scheduling, process planning, actual manufacturing, and up to the quality control and management. In these all stages, in all these phases, we are using the computer and computer technology. So this is known as computer aided manufacturing. So CAM is basically what? It involves the use of computer and computer technology in all the phases, in manufacturing. So which are these phases? We are having scheduling, then process planning, then we are having actually manufacturing, and quality control and quality management. In all these phases, there is the use of the computer or computer technology, togetherly known as computer aided manufacturing. Or in simple words, we can make the definition: whenever we are having the flexible manufacturing system on the floor, in this flexible manufacturing system, if we are adding or we are implementing the automatic storage and retrieval system, ASRS, and the inspection or the measurements of the parts or components are done with this computer measuring machine or coordinate measuring machine, that is CMM, coordinate measuring machines, then this togetherly, that is FMS is already implemented. In that we are having the automatic storage and retrieval along with the coordinate measuring machines. It is also known as the computer aided manufacturing. Please remember this. So this is the CAM. And when you talk about this integrated system, that is along with computer aided designing plus computer aided manufacturing, now we are getting the computer integrated manufacturing, that is the use of CAD plus CAM. We are getting the CIM, that is computer integrated manufacturing. Now after CAM, let us talk about this CIM. You can call it as CIM or CIMS. Okay, so here what is actually this CIM? That is the use of CAD and CAM togetherly, that is nothing but the CIM. But see, whenever all the departments in the industries are interconnected or integrated to the one another by using this computer, it is known as the computer integrated manufacturing system. So which are these all the departments we are talking about? Say directly from the stage of the ordering, then the product design, analysis, process planning, then manufacturing, up to the assembly and inspection, up to the dispatch. So all these activities which are the part of the organization, which are the various departments in the organization, these are interconnected with each other. It is known as computer integrated manufacturing system. So let us, I'm having here the business planning and support. Let's say I'm having here product design, here we are having manufacturing, here we are having assembly and inspection, so all the departments which are interconnected with each other, isn't it? So that we are getting this manufacturing without any interference from the human being. This is the CIM. Of course, every department are integrated with one another, with the use of course, the computer and computer technology, so that the production can be done without the human interference. This altogether is nothing but the computer integrated manufacturing system, CIMS. Now let us see what are the benefits that we are going to get. So if we talk about the benefits of CIMS, so number one, the responsiveness to shorter life cycle products, then the changing market, and the global competition. Definitely we are going to have the improvement in the response to this shorter life cycle products, changing market scenarios, or even the global competitions we are able to face, and that much response we can able to give to all these things. Okay, very nicely. That is one of the benefit of CIMS. Then we are having the quality and accuracy through the better process control. The quality, accuracy, or rather you can say the uniformity and accuracy through the better process control. That is the second benefit of the CIMS. Third benefit, that is the correct use or complete use of the material, machines, and the personnel, isn't it? Which will definitely increasing the production rate, that is productivity goes on increasing, that is production cost decreasing. Okay, and so यहाँ से लेना वापस. So the fourth benefit that we are going to get is the better control on the production, scheduling, and entirely on total manufacturing system. So these are the benefits of the CIMS. So dear students, in this way in this video we have learned about the computer aided designing, computer aided manufacturing and the computer integrated manufacturing system. So whenever the sequence is coming to the making for the product, so it will start with the first of all the design. Then we know it is converted into the drawing. After drawing, we are having the process plannings to make that. Then we are in reality we are manufacturing that product, and after manufacturing we are going to check whether it is made with the accurate dimensions or required demands from the customer end. Okay, so this is how the sequence is there when we are going to make the product, that is from the, and in every stage if we are using this computer, so definitely for the designing we are having computer aided design. So we can write like this: we are having first that is CAD, then for the drawing we are having computer aided graphics, then we are having the computer aided process planning, then and actually we are going to make, for that we are having computer aided manufacturing, and after making the product it will go for the quality checking, that is computer aided quality control, CAQC. So this sequence is generally followed by the product in this process, where in each stage, in each phase we have used the computer or computer technology. Thank you.